Hi, this is Mike Doran, Methane Mike. I want to talk a little bit about the melting Arctic and how electrics has played a big role in it. Right now, the Arctic is melting. It's one of the top 3 melt years on as far as recorded history is concerned. And the question is, why that's significant or important, and what does electrical conditions in the global electric circuit have anything to do with what we're seeing in the Arctic? My view is that carbon dioxide is significant not as a greenhouse gas, but it's the only gas in the atmosphere that when it gets into water, it dissolves and becomes an ion and then has a conductivity meaning in the atmosphere. And that conductivity meaning gets expressed in the Arctic, specifically right at this time of year in the middle of the summer, because the global electric circuit is at its peak. It's at its peak right now because the northern hemisphere has more land, and 90% of lightning occurs over land in the form of thunderstorms. Very few thunderstorms of lightning occur over the oceans. And so since the northern hemisphere has more land, you're going to have a greater current flowing in the global electric circuit at this time of year. And anytime you're talking about something that is changing something, or is like a device that requires energy to make it do something, you're talking about power, and they're very simple power formulas to simplify the way you look at something electrical. And one of those formulas is power equals current squared times resistance. And so what that means is if CO2 has a conductivity or resistance meaning, when the current is greatest by a power of the current squared, you're going to see it expressed. And that is why the global electric circuit, as it's in peak right now, is showing CO2 its true forcing, its true cloud feedback in terms of how clouds trap or release heat at this time when the global electric circuit is at its max. And that's why you're seeing the Arctic melt in the winter time as it is right now. Now this comes in the context of the fact that there are very slow solar conditions, relatively slow. The last time it was this slow was 1913, 1914, when we had the quietest tropical storm season on record. And it's why we were quiet this spring. It had nothing to do with El Nino. It had to do with the fact that these electrical influence, particularly X-ray, creates the X-ray activity from the sun creates added ozone, and when this ozone gets in electrical couplings or organizations, particularly over tropical storms, that ozone compresses down, causes subsidence, and in a very mechanical way alters the way tropical storms are quote-unquote sheared.